Hi everyone. Last couple of lessons we've had a look at the idea of surface area to volume ratio and we've related that to some aspects of biology and chemistry and cooking, and we also looked at the idea of heat sinks on a computer. So what we're going to do in this video is actually have a look at this in practice. So we're going to have a look inside a computer case, we're going to look at how the cooling is used to cool down the GPU, the graphics processing units, the graphics cards, and the CPU, the central processing unit or the processor. First of all, we're just going to have a start by having a look inside the computer itself, and then we'll look at what happens when it's being used.
Here we have the full look of the case. So if we look towards the very top of the screen there, you can just see the two fans there with the blue outline, which are cooling down the radiator. So that's just up here. If we go a little bit lower than that, we can see the two graphics cards. So the top card here is the 2080 Ti. The bottom one here, this blue one, is the 1080 Ti. So if we zoom in with those a little bit more, so you can see fairly clearly there that on the bottom one, blue area is the graphics card itself, but then just above it here, look, is the heatsink, and you can see how that heatsink is split up into lots of thin pieces of metal underneath it. So just going underneath from there are the two fans that blow air through the heatsink. The top card uses a different type of cooling, so this is what's called a blower card. So it's got a small fan just on top of it, so the fan is kind of just on top of there, and what that one does is it blows air out through the back of the card. So it does still have a heatsink, not quite as big as the other one. Just take a closer look inside here. You can just see there in the middle where we've got the cooler and the two pipes for the CPU, and again, like we were just looking before, so you've got the two fans at the top and the radiator there to cool those down.
So here on the desktop, got the monitoring software here. So this is the temperature here, 41 degrees for the 2080 Ti. That was the top card that we've just looked at. It wasn't showing much activity before, but because I've started recording now, it's just down here between that sort of 11 to 28%. So this is its percentage usage. The other card is not being used at all at the moment, which is why that one's down on 0. So this computer's been on for a while. Bottom card here is around it's there at 41 degrees. Sorry, the top card, the 2080 Ti, is at 41 degrees. The other card is running a little bit cooler. Two reasons for that: it's got the better heatsink and it's not being used. Yeah. And then underneath it we've got the fan speed. So I've got these set so both of these have the fans on at 25%. They're not working overly hard there at the moment. Yeah. Further down we've got here the CPU temperature, which is a little bit higher than the individual cores of the CPU. So if we bring up another monitoring program, then what this is showing us is that the liquid that is cooling down the CPU is at 32.6, and then the individual cores are there around 32, 33, maybe a little bit higher there, and this is what we call the package overall, which is what we're seeing here. But it does give us an indicator of where things should be. So let's just close that one down. So what we're going to look at to begin with, we're going to use two 3D rendering programs, 3D graphics programs, and we'll have a look at how it affects the temperatures and how the temperatures come back down with each of these. So our first one is going to be using the 2 GPUs, so it's just on the graphics card. So if we bring this one up, and then we're just going to set this to render. So just take a few seconds there, bring up the one on the side, so we can see already, look, the graphics card usage has gone up into the high 90s, and see how the temperature's gone up fairly quickly as well. Okay, so as it's building this image up, temperatures keep increasing because these cards are working particularly hard. And we're seeing also there, look, that the fan speed has gone up from 25 to 56%. This one, not so much, because the temperature's not gone up much because it's got that big heatsink on it, so it's losing heat much quicker than this one does. These 2080 cards run a little bit hotter anyway, that's also a factor. So this is just about finished. Right, so it's finished, the activity drops back down, and then we can see that the temperature starts to drop again as well, because the fans are blowing air through the heatsink, the smaller heatsink here, the bigger heatsink there. This one's almost back down to where it was before. This one will take a little bit longer because it's got a much smaller heatsink. It takes longer to lose that heat again. Also, in this case, it's still working a little bit because I'm recording now. What we're going to look at next then is the CPU. So that's the one that's liquid cooled. So we've got our kind of packaged CPU temperature here. These are the different cores of the CPU, so they're like sort of separate CPUs on this. So if we go to another program that is going to use the CPU, and we'll set this one rendering, and then I'll bring up again. So we see now all of the CPU cores have gone up to 100%, and straight away we've gone from around 40 something degrees up to into the 50s. But it's holding reasonably steady there whilst the rendering's going on. If we just go back up and look at the graphics cards, this one's still cooling down. Yeah, that one, the fan speed is back to normal now. The temperature's not far off from where we were before. So each of these, I can see now on the temperature, it's holding in the mid 50s because the coolant is still probably somewhere down around 40 something degrees. So this picture then is still building up, and whilst that's building up, it's using everything on the processor basically. Yeah, so it'll just keep on working with any of those. I'm not going to let this one finish. We'll stop this so we can see the temperature here on the CPU as these cores stop getting used. So if we stop that one and bring this back up. Okay, so there we're at 55 degrees, and just a few seconds later, look, we're back down in the 40s because the CPU cores are hardly being used again now. And that is down to, bring this program back up again. Because our coolant, our liquid that's going through, is at 35 degrees, any heat in that CPU, as soon as it stops working hard, it's just going to pass into the coolant, and then back on the computer itself, there's a radiator. Those fans are blowing air through the radiator. The radiator is split into very thin pieces of metal, so it's got a big surface area to volume ratio, which means it's going to lose that heat very, very quickly.